Hey, what's up, Unshape people? Mr. Palmer here. I'd like to go through this assignment because it can seem a little complicated here about what's going on. So what we're going to do is we're going to use the cams we created in the previous assignments, and we're going to place them into a 3D model. Once we have them in there, we're going to simulate the rotation of the cam. We're going to spin it. And we're going to study the motion of the follower. All right, hopefully you remember what the follower is. Then I'm going to collect data and create a graph to represent the motion of the follower. And once we do this for all the cams, we're going to compare the graphs and kind of come up with a model for displacement of the follower. So this is the video you're watching now, so that's why the link isn't highlighted. But what I want to do is I want to go ahead and show you how to get to my files, because I'm not asking you to start from scratch here. So what you're going to do is you're going to go on to Onshape, and actually, sorry, you're going to click this link, and that's going to bring you to my files. Now, because I am the owner of those files, me clicking that link wouldn't give you an authentic view of what you would be seeing. But what I want to do is I want to just find any public document here so you can kind of get a feel for what you might be seeing. So I'm just going to use these Brooklyn sunglass frames here. And hopefully when you click the link I posted, that's bringing you to my cam box assembly file. At this point, what you want to do is you want to make a copy for yourself. And you do that by clicking on one of these things here. What the heck do you do? Sorry. Oh, make a copy. All right, and then at this point you can give it a name, but for me, I named my file 4.5, and that's what activity it is. But you could call it whatever you want and say OK. And what's going to happen is it's going to move that file into your Onshape documents folder so that you can start editing it. And that's why it's important that you do this, because I made mine uneditable. All right, but this one is editable. You can go in and change whatever you need to change. You can change, go into extrusions and change those. You can change depths here. You can do whatever you need to do once you own the document. So the reason I'm showing you it with these eyeglasses is not because I want you to do it with the eyeglasses, but because I want you to come into this part, which is my shared version of the cam box assembly, and I want you to make a copy for yourself so that you could follow along. Now this is basically a box like we were going to make in class with an axle, a follower, and I also put a ruler here so that as we put the cams in there, we can measure the displacement of the follower up and down in that axis. I did mess up my axes a little bit, so that makes it kind of annoying, but I think we can work through it. So the first thing is, I will tell you that the snail cam is in here already. That's part one. And if you just show it, that's going to show the snail cam there. And here's the handle, so you can do different rotations. And you should be able to see that follower move up and down, right? So our goal is going to be to measure the height at the various angles of rotation. Now, for whatever reason, I don't know if it's Onshape or something I did, it doesn't quite do the full rotation. We can check every point, right? We can check that point and the point just before it, but we can't move in a smooth motion. So we're going to have to reverse it in order to check all the points. To aid you in the angle, I've included a little, I drew a little arrow pointer thing here. And what you can do there is just turn on the visibility for some of those angle markings. And that's going to show you, okay, that's at 0%, or sorry, 0 degrees. If you want to check 90 here, You know, you can just kind of see, okay, that's at 90, and our distance is roughly 2, and you might want to look right at that. 2 and a, what's that, 7/8. Okay, you can rotate that around to, oh, that's back to 0 degrees there. You can rotate that over, oops. Sometimes you got to turn that off or that thing gets in the way. Do that to, should be 180 degrees there. Yep. And that's at, oh, still 2 and 7/8. Rotate that around to, should be 90 degrees here. Let's just double check that. Oh, 270. Okay, 270. We're at 2.5 inches. And then we can even go to, did we check 90? I don't know. Is that 90? That's 270. Got to come around to there. Is that 90? Yeah, that's 90. And we're looking at 2 and 7/8 for that as well. So once you have all that data collected, you know, you can collect whatever you want, but basically we know it only moves in those at that one moment. Oh, no, we're down to 2 and 1/8 here at 0 degrees. And then, so make sure you're collecting accurate data. At some point, you're going to want to change that cam out and do this with a different cam. So I want to show you how to do that. The first thing I'm going to do is turn off the visibility of my snail cam by clicking on the eyeball here. Then I'm going to go in and insert one of my other cams. Now, they're not in this document. I did that on purpose so I could show you probably what you're seeing. You got to go to other documents. And I like to go to my Onshape or created by me. All right, at this point, you got to know which document you saved your cams in. Mine are in cam here. So I'm going to click on that, and I have 3 cams here to insert. The first one I'm going to try is the eccentric cam. So I'm going to go ahead and put that in. And actually, while I'm here, I guess I'll put in the other ones as well, because eventually I'll be checking all of these for their displacement. I actually don't have the pair in here right now, but you'll get the idea. All right, now assembly constraints are a little bit, well, they're kind of actually easier in Onshape, but if you're really good at constraints in Inventor, you're probably going to be frustrated like I was. But if you're a novice, if you're a beginner, you might actually find them to be a little more intuitive. So the first one we want to do is we're going to do a fastened mate. And the fastened mate is going to be so that this is locked to this rotating axle. If we do one of these other ones like rotate, then the axle will rotate through there and the cam won't move. So we basically want to glue it in there. That's called a fastened mate. And when you do that, be very aware of these axes that pop up, right? You see this blue, red, and green little axes thing that jumps in? Those are all points of where you could be gluing it. And we know we actually don't want to glue it in the center. We want to glue it from there. We don't want to glue it on the edge. We want to glue it right from there. And that blue line is our Z axis. So basically make sure yours looks exactly like this. It's going to mate it from that point. Now, in Inventor, you may be tempted to click on the axis at the end. In here, you can actually jump right to where you want to put it. And that's where it's going to go. So I'll show you both ways here. I'll show you the first one we want it, which is right there. And then I'll show you the other one. Where if we were doing an Inventor, we might be tempted to do that. And you can see how that's not where we want it. So I'm going to do it one more time. Fasten mate. I'll put that in that. and that right there. And I'll solve that. You might at some point need to change the direction and flip the primary axis. If you look at what's happening with that, not much on this part. But in other instances, that could be very useful. So there's that. You can see that takes up the majority of my space there. I'm wondering if I built it the wrong size. And then the final thing we want to do, yeah, that is very large. So I'm going to look at that, but that's how you get the cam in there. I'll show you with the hex cam next. Let me turn off that one. Yes. Now I'll put the hex cam in. Same idea. We'll go into fastened mate. Right there. And right there. And I'll solve for that. And now that's pretty good. If you notice, the cam follower isn't, it's kind of buried in there. So there's a final constraint we want to do, and that's usually known as in Inventor, it's called a transitional constraint. Here we can do it as a tangent, and I'm going to make it tangent to this edge. I'm going to make this round piece here tangent to that edge there.